Always remember that if the conclusion is true in every row of the truth table, in which of all premises are true, the argument is valid. If the conclusion is false in any row in which of all premises are true, the argument is invalid. So here is the given argument. If you finish your homework, you may watch the episode. You did not finish your homework, therefore you cannot watch the episode. So in our argument statement, we already have letters or symbols to use, and we make a truth table to determine the validity. So our first thing to do is we are going to translate our given argument into a symbolic form. This is the if then statement, so I use arrow symbols. So this is our first premises, second premises, and also the conclusion. Now we are going to put that in our truth table. The formula to know the number of row is 2 raised to n. N is equal to our statement. We have two statements, so 2 raised to 2 is equal to 4. So after that, in our table, we put the automatic truth value per statement. So we have H true, true, false, false, and E is true, false, true, false. To H then D is we have true, false, true, true. The negation of H is false, false, true, true. The negation of E is false, true, false, true. So we base this on the third and fourth row because the first and second premises are true. Now we look at the conclusion. The third row is false. The fourth row is true. So we consider it as invalid argument. Thank you.
Hi everyone, this is Nava Jinsi Agresino, a first-year BAT student. Now I am going to show you a mathematical logic and I am going to explain the statement that I made if it is valid or invalid argument. So, what are we waiting for? Let's start. The validity of the next argument will be determined by the statement. Let K represent the statement, I let my parents know that I would be going with my friends. And A represent the statement, my parent would not be angry. In symbolic form, the argument, if I let my parents know that I would be going with my friends, then my parents would not be angry. I don't let them know that I will be going with my friends, therefore they will get angry. We have here our first premise, K implies not A, which is if I let my parents know that I would be going with my friends, then my parents would not be angry. And second premise, we have not K, which is I don't let them know that I will be going with my friends. In our conclusion, which is A, therefore they will get angry. So for our solution, we have two symbolic forms, which is K and A. So we're going to solve it as 2 raised to 2 is equals to 4. So we have 4 rows in our truth table. For our K, we have here true, true, false, false. In our A, we have true, false, true, false. In our first prem, we have K implies to not A. So let's focus on our two symbolic form, which is K and A. So here, true implies to not true is equals to false. True implies to not false equals to true. False implies to not true is equals to true. False implies to not false is equals to false. So in our second premises, we have not K. So let's focus on our first symbolic form. Not P is equals to false. Not P is equals to false. Not false equals to true. Not false equals to true. In our conclusion, let's focus on our symbolic form A, which is true is equals to true, false is equals to false, true is equals to true, then false is equals to false. Row 3 is the only row in which all the premises are true. So it is the only row that we examine. Because the conclusion is true in the row 3, the argument is valid.
Given argument. If you study hard, then you will get high grades. You get high grades, therefore you study hard. Let P represent you study hard and Q represent you will get high grades. In symbolic form, the argument is P implies Q and the second premise is Q. The conclusion is therefore P. To determine whether it is valid or invalid, we construct a truth table. P, Q. First premise is P implies Q. Second premise is Q. And the conclusion is P. P is true, true, false, false. Q is true, false, true, false. The first premise is true, false, true, true. The second premise is true, false, true, false. And the conclusion is true, true, false, true. The argument is invalid because it shows that there is one false in conclusion. Regardless whether there are true in conclusion, as long as there is one false in conclusion, the result of the argument will be invalid.
Hi, I'm Jerica Ligas Pulabastida, and in this presentation, it's all about mathematical logic, and I'm going to explain if the statement that I made is valid or invalid. So, let's start. In this statement, we're going to determine the validity of the following argument. So, let P represent the statement my parents listen to my explanation, and U represent the statement they will understand. In symbolic form, the argument if my parents listen to my explanation, then they will understand. My parents did not listen to my explanation, therefore they do not understand. So for our first premise, P implies U, which is if my parents listen to my explanation, then they will understand. For our second premise, not P, which is my parents did not listen to my explanation. And for our conclusion, not U, which is therefore they do not understand. So for our solution, we have two symbolic form, which is P and U. So we're going to solve it as 2 raised to the power of 2 equals 4. So we have 4 rows. For our P, we have true, true, false, false. So for our U, we have true, false, true, false. So for our first premise, we have P implies U. So true implies true is true. True implies false is false. False implies true is true. And false implies false is true. So for our second premise, we have not P. So we're going to negate the P. So the true will going to be false. The true will be false. The false will be true. And the false will be true. So for our conclusion, we're going to do it the same as we did to our second premise. So it's not U. So the true will going to be false. The false will be true. The true will be false, and the false will be true. So have you noticed that the first, second, and the conclusion of row 4 is true? So row 4 is the only row in which all the premises are true. So it is the only row that we examine because the conclusion is true in row 4. The argument is valid.
Let S represent the statement I will study my homework, and B represent the statement I can play badminton. In symbolic form, the argument I will study my homework, then I can play badminton. I will not study my homework, therefore I can play badminton. So for our first premise, S implies B, which is I will study my homework, then I can play badminton. Then second premise, not S, which is I will not study my homework. Then for our conclusion, not B, which is I can play badminton. For our solution, which we have two symbolic form, S and B. So we have to solve it by 2 raised to the power of 2 equals 4 rows. S have true, true, false, false. B, true, false, S. The first premises is S implies B, true, false, true, true. The second premises S, not S, false, false, true, true. Conclusion, not B, false, true, false, true. And this conclusion, based on the result of the truth table, is we look on first, second, and third premises, only the rule 4 shows the row of 3 premises are all true. So this is the only row that we examine, which is results that the argument are valid.
Hello viewers. This is my given argument in mathematical logic in mathematics in the modern world. I will study for my board examination or I will play computer games with friends. I did not study for my board examination. Therefore, I did not play computer games with my friends. Now, let's assign variables in the argument. The I will study for my board examination statement will be the variable m. The I will play computer games with my friends statement is the variable r. The I did not study for my board examination statement will be the negation m. And lastly, the I did not play computer games with my friends statement will be the negation r. The symbolic form of the statement is m disjunction r, negation m, over negation r. Now let's look at the table. The first premises is m disjunction r. And the second premises is the negation m. And the third premises is the negation r. In variable m have a true, true, false, false. In variable r have true, false, true, false. In m disjunction r is true, 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 and false. In negation m is false, true, false, and true. Lastly in negation r have false, false, true, and true. In this conclusion, based on the result of the truth table, as we look in first premises, second premises, and third premises have no 3 trues in a row. Therefore, the argument is invalid.
Hello classmates, this is my given argument in mathematical logic in mathematics. Let B represent the statement, I will play basketball. Let L represent the statement, I will do my laboratory report. In symbolic form, the argument, I will play basketball or I will do my laboratory report. I will not play basketball, therefore I will do my laboratory report. And now, let's assign variables in the argument. I will play basketball statement will be variable B. I will do my laboratory report statement will be variable L. I will not play basketball statement will be the negation M. And the conclusion is the variable L, therefore I will do my laboratory report. In the symbolic form of the statement is B disjunction L, negation B over variable L. And let's look at the table. The first premise is B disjunction L, the second premise is negation B, and the third premise is variable L. In variable B, have true, true, false, false. In variable L, have true, false, true, false. In B disjunction L, have true, 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 false. In negation B, have false, false, true, true. Lastly, in the variable L, have true, false, true, false. In this conclusion, row 3 is the only row in which all the premises are true. So it is the only row that we examine, because the conclusion is true in row 4.
Hello everyone, this is my argument. If I went to school and I learned the lesson, I didn't went to school, therefore I didn't learn the lesson. So this is the symbolic form of this argument. If W, then L, therefore negation is L. This is the truth table of our argument. For W, we have true, true, false, false. And L, we have true, false, true, false. For our first premises, we have true, false, true, true. And our second premises, we have false, false, true, true. And our conclusion, we have false, true, false, true. And this is invalid.